Hi guys, today we're going to be talking about how to multiply rational expressions. The rational expression we're going to look at is the quantity x plus 2 divided by the quantity 6x squared minus 11x minus 10 multiplied by the quantity 12x plus 8 over the quantity 6x squared plus 12x. To make this easier to work with and to see if we can cross-simplify or cross-reduce anything, we're going to start by factoring everything that we can. So looking at the x plus 2 term, there's nothing they have in common, so we're going to leave it as is. The 6x squared minus 11x minus 10, we're going to use a generic rectangle to help us factor. When working with your generic rectangle, you always want to put in your x squared terms and your unit terms diagonally from each other. For this generic rectangle, we know that our x terms need to multiply to the product of 6x squared and negative 10, but add to negative 11x. So we're going to use a diamond problem to help us set that up. So in the top of my diamond problem, I'm going to put negative 60x squared. And in the bottom of my diamond problem, I'm going to put a negative 11x. So the two terms that do this are going to be negative 15x and a positive 4x. Put those into the generic rectangle in the two empty spaces. And then start factoring out what each column and row have in common. So 6x squared and negative 15x have a 3x in common. 4x and negative 10x have a 2 in common. 6x squared and 4x have a 2x in common. Negative 15x and negative 10 have a negative 5 in common. Just to be sure that everything worked, make sure that your outside of your generic rectangle multiplies and gives you the inside of the generic rectangle. Now looking at the term 12x plus 8, there isn't an x squared in it, so I'm not going to try to use a generic rectangle. Instead, I'm going to look and see what they have in common. 12x and 8 both have a 4 in common, so I'll go ahead and factor a 4 out of both of those. Looking at the bottom, I notice that they have a greatest common factor of a 6x in common, so I will factor a 6x out of both of those. So when rewriting this, the numerator of my first rational expression will stay x plus 2. The denominator will become what I factored with my generic rectangle. So we'll have the quantity 3x plus 2 times the quantity 2x minus 5. Multiplied by, remember we factored a 4 out of the top of the second one, so we have 4 times the quantity 3x plus 2 over, we factored a 6x out of both of those terms, so we have 6x times the quantity x plus 2. This is a good point in your work to start to make sure that what you've rewritten is equivalent to what you started with. So x plus 2 and x plus 2 are equivalent. When I multiply the 4 by the 3x and the 2, I get back to the 12x plus 8. So you have to make sure that that 4 is written there. Otherwise, your expressions are no longer equivalent and you've changed the value of what you're working with. Something that I like to do from here is I like to rewrite anything else that can be further factored. So for instance, 4 can be rewritten as 2 times 2, and 6 can be rewritten as 3 times 2. So I would actually take this entire expression and I would rewrite it as x plus 2 over 3x plus 2 times 2x minus 5. And then I would rewrite my 4 as 2 times 2 times 3x plus 2. This will help me see things I can simplify and make my process a little quicker. I would rewrite 6 as 3 times 2 times the x plus 2. So now remember, when we have two fractions that we're multiplying together, we are going to take the numerator times the numerator, the denominator times the denominator, and then simplify. Or we can try to simplify first by doing cross-simplifying or cross-reducing to make our work a little easier. For instance, there is a 3x plus 2 in the numerator of the second and a 3x plus 2 in the denominator of the first, so those can cross-reduce and make a giant 1. We have a x plus 2 in the numerator of the first and x plus 2 in the denominator of the second. Those cross-reduce and make a giant 1. And then because we rewrote our 4 as 2 times 2 and our 6 as 3 times 2, we notice that we have a giant 1 with these 2's right here as well. All right, guys, now that we've cross-reduced, we can multiply our numerators and multiply our denominators. So technically, we have 1 times 2 times 1 times 1. So on the numerator of our new fraction, it'll simply just be 2, because 1 times 2 is 2, 2 times 1 is still 2, and 2 times 1 is still 2. In the denominator, we have 1 times 2x minus 5 times 3 times 1 times x times 1. And I can take the numbers, so the 1, the 3, the 1, and the 1, multiply those together, it gives me 3. I have an x, and then in parentheses, I have a 2x minus 5 that's stuck together. At this point, it's good to check to make sure that your numerator and your denominator don't have any factors in common so that you can't simplify any further. So for instance, the 2 and the 3 don't have any factors in common, and because 2 is the only thing in the numerator, this is as far as you can simplify the numerator and the denominator. If you wanted, you could rewrite the denominator by distributing the 3x to the 2x and the minus 5. So it's okay to write it as 2 over 3x times 2x minus 5, or you can write it as 2 over 3x times 2x is 6x squared, and 3x times negative 5 is negative 15x. The last thing that you need to make sure you indicate are the values that x cannot be, so the excluded values from this expression. So remember, when we have division, we cannot divide by 0. So what you'll want to do is you'll want to go back up to where you have everything factored and figure out the values of x that would make your denominators equal to 0. So in this case, the 3x plus 2, you would set it equal to 0, solve. The 2x minus 5, set it equal to 0 and solve. The 6x, set it equal to 0 and solve. The x plus 2, set it equal to 0 and solve. So in this case, x cannot equal negative 2/3 from the first one, 5/2 from the second one, 0 from the 6x, and negative 2 from the x plus 2.